Atomic number and mass number. Now let us learn about the atomic number. From the alpha scattering experiment, Rutherford and his associates established the presence of positive charge in the nucleus of an atom due to protons, and estimated the number of positively charged nucleus of the atoms on the metal foil. They used different metal foils and found the number of positive charges present in each case. Rutherford was the first to establish in 1919 the independent existence of particles called protons, which are the fundamental unit of one positive charge. He found the existence of protons by the studies carried out on the passage of alpha particles in hydrogen. Henry Moseley, under the guidance of Rutherford, tried to determine the exact number of positive charges present in the nucleus of an atom. He stated that the number of unit of positive charges present in the nucleus of an atom is known as the atomic number of the element. It is denoted by the symbol Z. We know that all the protons are present in the nucleus of an atom and each proton has a unit positive charge. Therefore, the atomic number of an element is the same as the number of protons. In an atom, protons and electrons are the same in number since the atom is electrically neutral. Therefore, the atomic number of an element must also be equal to the number of electrons. Thus, atomic number is equal to number of protons, which is equal to number of electrons. We already learned that protons and electrons are constituents of atoms. But on taking into account the protons and electrons, all the mass of atoms cannot be accounted for. Let us take an example. Atomic mass of hydrogen is 1. Its nucleus contains 1 proton. But the atomic mass of all other elements cannot be correlated to number of protons in the nucleus. Let us take an example. Atomic mass of helium is 4. An atom of helium has 2 protons and 2 electrons. As charge is balanced, therefore an atom of helium as a whole is neutral. Because mass of 2 electrons is negligible, therefore mass of helium should be 2 due to the presence of 2 protons, each having a mass equal to 1 atomic mass unit. In order to account for the remaining mass, existence of a neutral particle having mass almost equal to that of a proton was proposed. Presence of 2 neutral particles in the helium atom can make the mass of helium equal to 4. James Chadwick was successful in discovering the neutral particle, neutron, inside the nucleus. Let us see how he did it. Let us now learn about discovery of neutrons. When James Chadwick bombarded a thin sheet of beryllium element with alpha particles, then he observed the highly penetrating rays which consisted streams of neutral particles. Each neutral particle present in the obtained rays was having no charge but was having a mass of 1.67 into 10 to the power minus 27 grams, which was nearly equal to that of a hydrogen atom. The new particles formed were given the name of neutron and denoted by the symbol N. Thus, neutron may be defined as a fundamental particle present in the nucleus of an atom which carries a mass of 1.67 into 10 to the power minus 27 kilogram, regarded as 1 unit mass and no charge. We have studied the 3 subatomic particles that is electrons, protons and neutrons. Out of these, protons and neutrons are present in the nucleus, while electron is present in the extranuclear portion. We can sum up this information as follows. Proton, symbol P+, with a mass of 1.67 into 10 to the power minus 27 kilograms and a charge which is equal to 1.67 into 10 to the power minus 19 coulombs. Electron is E minus with a mass which is equal to 9.1 into 10 to the power minus 31 kilograms, which is negligible, and a charge of 1.67 into 10 to the power minus 19 coulombs. Neutron is denoted by the symbol N with a mass of 1.67 into 10 to the power minus 27 kilograms and no charge. Remember that electrons, protons and neutrons do not have any identity as such. Atom is still the smallest particle of matter which is involved in chemical combination with other atoms. Protons and neutrons present in the nucleus of an atom are also called nucleons. Let us now learn about the mass number. The discovery of neutrons by Chadwick made it quite clear that the nucleus of an element has protons and neutrons, as well as an explanation of emission of negatively charged beta particles from nucleus and also the mass of an atom. The original prediction by Rutherford proved to be correct. Since each proton and neutron has mass equal to 1 atomic mass unit, therefore, mass of an atom must be the same as the sum of protons and neutrons present in the nucleus. The latter is known as a mass number of an element. It is denoted by the symbol A. The mass number of an element may be defined as the sum of the number of protons and neutrons present in the nucleus of its atom. Let us learn about composition of atom. From our discussion so far, we conclude that an atom is electrically neutral. That is, it has no charge. In an atom, protons and neutrons are present in the nucleus and electrons in the extranuclear portion. Atomic number of an element is equal to number of protons in the nucleus. Mass number is the sum of protons and neutrons present in the nucleus. Atomic number is equal to number of protons. Mass number is equal to number of protons plus number of neutrons. That is, atomic number plus number of neutrons. For example, the mass number of the element aluminium is 27 and its atomic number is 13. Therefore, number of protons is equal to atomic number, which is equal to 13. Number of electrons is equal to number of protons, which is equal to 13. Number of neutrons is equal to mass number minus atomic number. That is, 27 minus 13, which is equal to 14. When an atom loses an electron, it forms positive ions. But there is no change in the number of protons. There is no change in the nucleus. For example, sodium with atomic number 11 forms Na plus ion after losing one electron, but its atomic number is still 11. The number of electrons in sodium ion is one less than the electrons present in neutral sodium atom. We will now learn about the representation of an atom. The atom of an element is generally represented by the symbol of that element. The atomic number is indicated on its lower left side of its symbol, say Z, and the mass number on its upper left-hand side. The mass numbers and atomic numbers of some elements may be shown as represented on the screen. Let's now discuss an example. There are 15 protons and 16 neutrons in the nucleus of an element. Calculate its atomic number and mass number. How will you represent the element? And now the solution. Atomic number of the element is equal to number of protons, which is equal to 15. Mass number of the element is equal to number of protons plus number of neutrons, which is equal to 15 plus 16, that is 31. Representation of the element is 31x 15. The element with atomic number Z equals 15 is actually phosphorus. It is represented as 31p15. Let us take one more example. The symbol of oxygen atom is 16O8. What is the name given to the number of protons in the nucleus of the atom? Solution. Number of protons in the nucleus of the atom is known as its atomic number. Atomic number of oxygen is equal to 8. What is the name given to the number of protons plus number of neutrons in the nucleus of the atom? Solution. Number of protons in the nucleus plus number of neutrons in the nucleus is known as its mass number. Mass number of oxygen is equal to 8 plus 8, that is 16. For each atom, determine the number of neutrons in the nucleus and give the number of electrons present outside the nucleus. Solution. Atomic number of fluorine is 9. Number of neutrons is equal to 19 minus 9, that is 10. Number of electrons is equal to 9. Atomic number of iron is equal to 26. Number of neutrons is equal to 56 minus 26, that is 30. Number of electrons is equal to 26. Atomic number of copper is equal to 29. Number of neutrons is equal to 64 minus 29, that is equal to 35. Number of electrons is equal to 29.